Hello everybody and welcome back to Be Pharmawise. In this video, we are going to discuss the titration curve for precipitation titrations. Now we are already discussing the precipitation titrations. In the earlier video, we have discussed the basics of precipitation and also the solubility product and the factors affecting solubility of a PPT. So if you haven't checked that video, I'll link it somewhere here or in the description box. Check that video out, and this video will deal with titration curve of precipitation titrations. So basically what we will do is we will plot a curve, a graph, wherein looking at the entire course of titration of a precipitation reaction. Now we have already plotted the titration curves for our aqueous acid base titrations, and you will find those videos on my channel also. But talking about this particular video, precipitation titrations, what are the precipitation titrations? Let's take an example of sodium chloride being reacted with silver nitrate to form silver chloride PPT. Now this is a precipitation reaction, and this titration we can carry out. So what we will do is we will take 50 ml of 0.1 molar NaCl solution in the conical flask, and in the burette I am going to fill 0.1 molar silver nitrate solution, AgNO3 solution. So this is going to be my analyte, this is going to be my titrant. And now let's begin to plot the curve. So what we are going to plot on the curve, I'll draw here. So this curve is usually plotted on x-axis. We take the volume of titrant added. So here in this case, volume of AgNO3 added will be on the x-axis, and the variable we take on the y-axis. Now during the course of titration, what is going to happen? Initially there are only chloride ions in the conical flask. As soon as AgNO3 falls down and they start to react, the chloride ions are now forming the PPT. So they are getting depleted from the solution. So obviously if I plot the concentration of chloride ions, I will get to know something regarding the course of titration. So what I will do, like concentration of chloride ions will have negative into 10 raised to negative something values. So it is better if I take PCl minus values, like we take pH for aqueous acid base. We don't plot H plus ion concentration, but we go for pH values. Similarly here we will go for P chloride ion. So PCl minus values we will plot on the y-axis. Now let's discuss how this curve can be plotted. So first condition we will take is before titration begins. So what will happen before titration begins? Now as you can see, there are only chloride ions present in the solution before titration begins. So if I want to calculate the concentration of chloride ions, how I can do? I can calculate the concentration of chloride ions by simple formula, molarity of chloride ions into volume of chloride ions upon what is the total volume of solution. So total volume of solution at the moment is 50 ml, and molarity I have taken 0.1 molar, and volume, initial volume of NaCl is again 50 ml. So 0.1 into 50 upon total volume is currently 50. So if I solve this, obviously the answer will come 0.1. Now this is chloride ion concentration 0.1. And if I want to calculate PCl minus, then I'll have to take negative log of concentration of Cl minus. So negative log of 0.1 will definitely come 1. You can solve this easily on a calculator and you'll get the values. So PCl minus value is starting from 1. So if I take 0 here, 10, 20, 30, 40, 50 like values here, 1, 2, 3, 4, 5, 6, 7, 8, 9, these values here, then my graph is going to start from somewhere here. Okay, now let's discuss what will happen during the course of titration. What is the case during the titration? So as soon as my titration begins, say let's take an example, my titration has begun and 25 ml of AgNO3 has fallen down. So 25 ml of AgNO3 is reacted with 25 ml of NaCl. So now what is the case? AgNO3 25 ml has been added to the conical flask. So if now I want to calculate the concentration of chloride ions, I will use the same formula. Molarity will not change. So 0.1. Volume of chloride ions. See, now NaCl has been consumed. 25 ml NaCl has been consumed. So only 25 ml is left. So I will take 25 here. And total volume 50 ml of NaCl plus 25 ml of added AgNO3. So total volume has become 75 ml. So if I solve this, I will get so if I will get something like 0.33 kind of answer, and the PCl minus value, if I solve, then it will be around 1.5 to 2. I have not solved it. It is very easy to calculate from a calculator. You can do it. Just understand the concept. So basically the value is not differing much from 1 and 2. So the graph is going for 25 ml addition. The graph is growing slowly like this. So again, even for 45 ml of addition, the graph is going slowly like this. Okay, I'll plot it like this. Slowly the graph is rising. Now we have reached the point where, now I will clear this. Now I have reached a point of equivalence, means 50 ml of at equivalence point. So 50 ml of AgNO3 has fallen down and it has reacted completely with 50 ml of NaCl, and now we have reached the point of equivalence. So what will happen at this moment is concentration of Ag plus ions and concentration of Cl minus ions is now equal, right? Because chloride ions which were initially in excess are now neutralized or used by Ag plus ions, and now both their concentration is equal. Now we know the equation, the concentration of Ag plus into concentration of Cl minus at equivalence point will be our Ksp value, right? And as both of their concentration is same, at equivalence point I will write Ag plus is also Cl minus. Cl minus is Cl minus is equal to Ksp. So concentration of Cl minus square is Ksp. So Cl minus concentration can be calculated as under root Ksp. And I know the Ksp value, it is 1.2 into 10 raised to minus 10. So if I take square root of it, I will get Cl minus value. And if I take PCl minus, if I take negative log of it, I will get the answer 4.96. You can solve it, but you will get the same answer, 4.96. So this is the chloride ion concentration log at equivalence point. So you can see from around 2, the value is directly rising to 4.96, means literally 5. So this is how the drastic change is happening in the curve, and it is indicating the end point of titration. Now what will happen after equivalence point? So what we have done so far is we have used the chloride ion concentration. We have used the simple formula, molarity into volume upon total volume. But now after equivalence point, we cannot calculate chloride ion concentrations because they are no more in excess. They have been precipitated. So now after addition of excess of AgNO3, now I have to decide the concentration of Ag plus ions, and I will use the solubility product equation to calculate it. So what I will do after equivalence, see, after equivalence Ag plus ion concentration can be calculated by our usual formula, molarity into volume upon the total volume. So now suppose 5 ml of AgNO3 is added in excess. So what I will do, AgNO3 molarity is 0.1, volume 5 ml AgNO3 has been added, and now total volume is 50 plus 50 plus 5. So it is going to be 105. Right? So this is how I will solve this. then I'll get Ag plus concentration. I'll take negative log of it, then I'll get PAg plus value. And you know the equation Ag plus into Cl minus is Ksp. So if I take negative log of each of the term, what I'll get? PAg plus PCl minus will be PKsp. Yes. So if I am getting PAg plus, I have the value of Ksp. If I take negative log of it, I'll get PKsp. So I have PAg plus, I have PKsp. I can easily decide my PCl minus value. So after equivalence point, chloride ion concentrations will be calculated using the solubility product equation. And then I'll plot that value. And if I plot that, again it will be like this. So the graph will be usual titration curve graph with this shape and having a drastic change at the midpoint near the equivalence point. And if you plot the midpoint of this curve or this change, this portion, it will give you the equivalence point of that particular titration. So this is how we are going to plot the titration curve for precipitation titration. But wait, we have to consider a few things before we start with the precipitation titration. The first thing, the concentration of reagent and your titrant has to be more, means the solutions has to be concentrated. Don't go for dilute solutions, otherwise the precipitation won't be completed. Then what you can consider for a precipitation titration is select a salt whose Ksp value is small. Smaller the Ksp, easier it is to exceed the value and easier it is for the precipitate to form and go to completion. So go for concentrated solutions and choose a salt with smaller value of Ksp, and then you will get accurate and sharp endpoints in the precipitation titration. Now in the next video we will discuss all the methods of endpoint detection in precipitation titration. It is going to be a very important video because that question is always asked for 10 marks in the university exams of analysis. So if you want to get notified, then press the bell icon and subscribe to the channel, and I'll meet you in the next video. Till then, you take care. Bye bye.